This is the Matter Model Chemistry project by Simon Yoon and Jungho Daniel Choi from 8C. For this project, we will be using fluorine as the main example in which we will demonstrate the concepts that we are going to explain, these concepts on chemistry. Now, fluorine is the ninth element in the periodic table, and its atomic symbol is just one letter, F. It has an atomic number of 9 and an atomic mass number of 19. In its stable form, in a neutral atom, there are 9 protons, 10 neutrons, and 9 electrons. Now, while we will be using two-dimensional models to demonstrate our concepts, it's important to remember that not only is an atom three-dimensional, but also there is the presence of an electric cloud rather than set orbitals. What I mean is, if you look at two-dimensional models, what you will see is that the electrons are following set paths that just go around and around orbiting the nucleus. In fact, when you look at an actual atom, that's not what happens. A more accurate description would be a cloud of electrons. This cloud being the place with the highest probabilistic chance of there being electrons there. Electrons can be theoretically anywhere from the nucleus. It's just that they're most likely to be within that electron cloud. Now, there are three different types of atoms I will be talking about. Fluorine has a pretty even balance of protons and neutrons. In a neutral atoms, there are 9 protons and 9 neutrons. In a neutral atom, there must be the same number of electrons as protons to keep a neutral charge over everything. And isotopes are when you actually have more or less than the standard amount of neutrons in an atom. So isotopes can be caused by things like the decaying of heavier elements, which will lead to a loss of protons, and that means the element is changing to a lighter element, but the number of neutrons might stay the same, which means that it has a higher number of neutrons than its standard in a neutral atom. So that would make it an isotope. Now, ions are when you have more or less electrons in the outermost shell of the energy levels in electrons. So the valence electrons are the electrons in the most outermost shell, and atoms like to have that valence shell completely filled up to its maximum amount of electrons that it can hold, and that's when you call it stable. Now, noble gases are very stable, and you would rarely see noble gases forming ions because they don't want to lose or gain more electrons. Now, ions are used to form ionic bonds, but we'll get into that later. Now, just an interesting fact, the lightest element with no stable form at all, meaning that it decays in every single form, is technetium, the 43rd element. The fluorine-18 isotope is an isotope in which there are less neutrons than usual within the nucleus of the fluorine atom. This is one way you can write the fluorine-18 isotope. The other way you could write it out is to write fluorine-18. To create the fluorine-18 isotope, what is happening is that from a neutral atom, a neutron is leaving the nucleus and making its way past all the electrons to the outside of the atom, and this neutron, as it escapes, it lessens the mass of the nucleus of the atom, thus creating a fluorine-18 isotope. This details the formation of the fluorine-21 isotope, a very unstable isotope of fluorine. Again, This is another way to write out fluorine-21 isotope. You could also write it fluorine-21. This is how a fluorine-21 isotope might be created. In this scenario, two neutrons are coming in from the outside and getting through the electron cloud and attaching themselves to the nucleus of the fluorine atom. In another situation, it could be that a heavier element is decaying and losing protons while the neutrons remain. Therefore, fluorine is created, but with extra neutrons. Both of these scenarios are possible. This will depict the formation of a negative ion, meaning that there are more electrons than normal. To form negative ions, there needs to be extra electrons. Now, fluorine is an element that will form negative ions very easily because there is just one space left in its outer shell of electrons. Now, this electron will come from an outside atom and become part of the fluorine atom, meaning that the overall charge becomes negative. While we are discussing the formation of positive ions, it should be noted that fluorine is not an atom that forms positive ions. In fact, it very rarely does. But this is the process in which it hypothetically might form a positive ion. This is the process in which a fluorine atom might hypothetically form a positive ion. Here, 3 electrons are escaping from the outer shell and going off to some other atoms. Now, this means that the charge becomes more positive and the atom gets an overall positive charge.